Hello everyone and welcome back to Diksha Karnataka YouTube channel. So today we are going to discuss KCET 2023 paper in detail. So first we are going to discuss from question number 1 till question number 30, and then we are going to discuss question number 31 till question number 60. We have already completed KCET 2024 discussion. If you have not seen that video, there are two parts on that also, from 1 to 30 and 31 to 60. So that will be given in the pinned comment below. Don't forget to watch that as well. So if you are preparing for KCET 2025 exam, then I hope this will give you much better preparation, what questions you can expect, what type of questions, and which of the questions you don't need to study, because some of the questions in the previous years are now deleted. So we are going to discuss everything in detail, in depth. Also, some of the questions may be little important if you are preparing for JEE Mains exam. So let's start without keeping you waiting. If you want, you can find the download question paper and then try to solve yourself, and then you can see this video and clarify whatever doubts that you may have. So first question: a block of mass m is connected to a light spring of force constant K. The system is placed inside a damping medium of damping constant B. The instantaneous values of displacement, acceleration and energy of the block are x, a and e respectively. The initial amplitude of oscillation is a, and omega dash is the angular frequency of the oscillations. The correct expression related to the damped oscillation is, the incorrect expression related to the damped oscillation is, there are three correct options and one of them are incorrect. But before I solve this, I should mention that damped oscillation is no longer part of your syllabus. So currently this is out of syllabus, but you should know that only thing that separates is this x. Okay, in every damped oscillation, if you are writing this, there will be a t term and there will be a minus term. Okay, because the amplitude is decreasing over time. So this expression is wrong. Otherwise, all the other expressions are correct. Now, the speed of sound in an ideal gas is given by given temperature T is V. The RMS speed of gas molecules at that temperature is V RMS. The ratio of velocities V and V RMS for the helium and oxygen gases are x and x dash respectively. Then x by x dash is. So it is a very easy question. We know that V by V RMS for any gas is given by square root of gamma by 3. If you want how this thing came, you can mention that in the pinned comment below. I will make a short video to explain how this formula is derived. Now, this is not V, this is gamma, okay? Gamma means the ratio of Cp by Cv. Now for helium, it is x. So for helium, it will be gamma helium divided by 3. Now what is gamma helium? Gamma helium is a monoatomic gas. Okay, so for monoatomic gas, gamma is 5 by 3. Remember this. For monoatomic gas, it is 5 by 3. For diatomic gas, it is 7 by 5. Okay, for triatomic gas, it is 9 by 7 and so on. Okay, if you remember this, this will help your life. It will make your life very easy. Okay, so the gamma for monoatomic gas is 5 by 3. So for oxygen is a diatomic gas. So for that it will be 7 by 5. So for helium it is this. For oxygen, gamma O2 is this. Okay. Now if you take the ratio of these two, if you see there is a 3 divided in both cases. So these 3 will cancel each other. So what we will left with? We will left with x by x dash. You are supposed to find x by x dash, that is equal to gamma of helium divided by gamma of oxygen. Okay, now gamma of helium is, yes, 5 by 3, and gamma of oxygen is 7 by 5. So we just insert the values and see what value we are supposed to reach. Okay. So 5 by 3 divided by 7 by 5. So it will reach to, this 5 will go up, 5 times 5. The last one, the bottom one goes the topmost. Okay, and the middle ones, they share each other. Okay. So it will be 5. Square root is there. So 5 into 5 times 5 square root is 5 and square root of 21. So the correct option is 5 divided by 21, that is option A. Okay. Now, next question. A positively charged glass rod is brought near an uncharged metal sphere which mounted on an insulated stand. If the glass rod is removed, then the net charge on the material sphere is. So it was mentioned that a metal sphere mounted on an insulated rod and a glass rod with charge, say positively charged, yes, positively charged is mentioned, it is brought near. Brought near means it is not touched and nothing else happened. It was brought near and then it is removed. It is brought near. So when it was brought near, what would happen? When it was brought near, this side will have negative charge, this side would have positive charge. That is called charging by induction. But when it is removed, then what will happen? These charges again, they will recombine and total charge of the metal sphere will remain 0. Okay. As long as you are not grounding the other side, as long as you are not touching it, nothing else will happen. It will remain 0. Okay. This is the answer. Now, next question. In a situation shown in the diagram, magnitude of Q very less than capital Q. So here as diagram is shown, here minus Q is there, here plus Q is there, there is a test charge minus Q. Okay, and it is mentioned that R, this distance R is very greater than this distance A. Okay, this distance, any half of the distance A. The torque on it, so the net force on the free charge minus Q and net torque on it at O at instant shown respectively is. So now what we have to do, we have to find the net force as well as we have to find the net torque acting on it, right? Now you can do the mathematics, you can do all the mathematics you want, but that will make the things complicated. What we will do, we will use smart logic, we will use smart elimination. So first thing, you can see there is an expression for force and there is an expression for torque for each of the pair. Okay, what else is there? There is a direction given. Okay, k cap, I cap, I cap, k cap. Okay, k cap, I cap. Also there is a sign given, plus or minus. Okay, we will only consider the caps, that is the direction, and what is the sign. So if it is along the positive axis, it will be positive k cap. Positive x axis means positive I cap. It is positive z axis means positive k cap, and vice versa. So we will only consider the direction to solve this problem. You do not need to do all the mathematics to solve this problem. This is called smart reasoning, smart logic. Okay, so first we will find what is the direction of force on this negative Q due to this positive charge. So this positive charge will definitely attract it, right? Opposite charges attract each other, so it will attract it, and this negative charge will repel it, right? Now we have already done similar case in case of dipole, okay, where we are trying to find the electric field and we are sure that this is along the direction towards the x axis, right? This is x axis, this is x axis, this is y axis. Okay, now what is the z axis? How can we find the z axis? You just take your right hand, you move from x to y, whatever your thumb points out, that is the z axis. Z axis in this case is out of the screen. Z axis in this case is out of the screen, right? So positive z axis is out of the screen and negative z axis is towards the inside the screen. Okay, negative z axis is inside the screen. So now if you see, this is along positive x axis. Positive x axis means this must be I cap. So wherever we have positive I cap, that could be our possible answer. So one of them is this, another one is this. Okay, so these two are our possible candidate for the answer. What else? What else? We have to find the direction of torque. Okay, how to find the torque? So R is pointing in this direction. This is the direction of R, right? R is pointing from the dipole towards this. So this is the direction of R. This is the direction of vector vector F, and we know that torque is given by R cross F, right? Torque is given by R cross F. So we will start with the direction of R. We will start with the direction of R and we will move towards the direction of force F. Okay, so we will start in the direction of R and we will move towards the direction of F, and wherever our thumb is pointing, that is inward, that is the direction of torque. So torque is pointing inward. Inward means which direction? Negative z axis. So negative z axis. So it is negative z axis. So negative z axis means this option, right? So the correct answer is this. So without doing any difficult mathematics, only by using logic and some diagrammatical knowledge, we are able to solve this kind of problem. So if you are using your brain properly and if you have trained yourself properly, you don't need to do difficult mathematics always. You can simply use your logical answering, logical reasoning to find the correct answer. Okay. Now in some case, for example, if you are writing JEE exam, this is the difference between JEE exam and KCET exam. If you are writing JEE exam, they will give you same direction but the values will be different. In that case, you have to do the mathematics. That is why JEE is difficult than KCET. In KCET, they have given you the options such a way that if you find the direction properly, you don't need to calculate the forces. That is the logic. Okay, that is the logic they want to test if you are able to answer this difficult question quickly or not. Okay, they don't want to, if you sit here and start calculating, okay, what is the force, what is the torque, it will take a lot of time. But if you use this logic and if you find the direction, it is very simple, right? Pressure of an ideal gas at constant volume is proportional to so we know that pressure of an ideal gas, PV is nRT, right? Now at constant volume means PV is proportional to T. Okay, N, R are constant. Now P is proportional to T means what T represents? T represents the average or total energy of the gas, average energy of the gas or total energy of the gas. So we can say that it is dependent on total energy of the gas. Okay, total energy of the gas. Electric field at a distance r from an infinitely long uniformly charged straight conductor having linear charge density lambda is E1. Another uniformly charged conductor having the same linear charge density is bent to semicircle of radius r. The electric field at this center E2. Then, very interesting question. First of all, if you see infinitely long uniformly charged straight to conductor, so it is a very long. So infinitely long charge conductor, if you bend it and if you make it a circle, even after making it a circle, the rod will still be infinitely long. Okay, you can still take it as a straight wire, because we know that the radius of curvature for a straight line is infinity, right? So basically what you can do, if you are taking a straight wire and then bending it, even after bending it, it will still remain infinitely long. That is the definition of infinity. So they are playing with the definition of infinity. So since the rod is infinitely long and even after bending it, it will still remain infinitely long, and you can still consider it as a straight line. So you can write E1 will be equals to E2. So basically they are trying to fool you in this case. Okay. Now 5 capacitors each of value 1 microfarad are connected as shown in the figure. The equivalent capacitance between point A and point B is. Very, very important question. They are connected here as well. This is not clearly visible, but they are connected here as well. So what we have to do, we have to connect this to a virtual battery. This is the circuit. Okay, now you have to apply something. Let me redraw this so that you can get a familiar picture. So if you draw this as, can I draw this? Let me show you. Can I draw this? See, this capacitor is between this point and this point. So instead of drawing like this, I have drawn this like this. Can I draw this? I have removed this part. Okay, I have just directly connected it. Similarly, for this part also I have directly connected it. Right? Similarly, I have done for the bottom one as well. Now, if you see, all the capacitors are equal. 1 microfarad, 1 microfarad, okay, 1 microfarad, 1 microfarad. Now, no matter whatever is the capacitance of this, as we have studied in case of Wheatstone bridge, that if these 2 points have same potential, then there is no current through the galvanometer. Now, because of the symmetry of the circuit, we can easily assume that there is no, the potential difference between these 2 points is 0, because whatever potential difference is here, same potential will be here, because they are symmetric. So we can write that these 2 points have same potential difference, and we can simply remove this capacitor. Okay, remove this capacitor. Only one capacitor, only these 4 capacitors will be left with. So now we can solve it easily. These 2 capacitors is in series, and then the combination is in parallel. So 2 capacitors in series, same value. I told you in our KCET 2024 discussion about resistors that when 2 same resistors are in parallel, what is the value? Similarly, when 2 capacitors are in series, the value is basically C by 2. When 2 equal capacitors are connected in series, their equivalent capacitance is C by 2. So we can draw this capacitor as this and this. So what is the capacitance of this? C by 2, that is 0.5. Similarly, these 2 are also 1 microfarad, so this will also be 0.5 microfarad. Now they are in parallel. Parallel means they are just simply gets added. So added means the equivalent capacitance is 1 microfarad. Okay, you just need to use your head a little bit and find the answer. Okay, this is little bit tricky, but if you know how to solve it, you can easily solve it. Now, next question. A uniform electric field vector E exists along the horizontal direction as shown. So the electric field exists in the horizontal direction as shown. The electric potential at A is VA. So it is given at A, it is VA which is given. Okay. Now, a small point charge Q is slowly taken from A to B along the curved path as shown. It was taken along this curved path as shown. The potential energy of the charge when it is at point B. So the potential energy of the charge at the point B. So that's what we have to find. Now remember that to solve this question, you have to remember few things. First of all, if we can find the potential at B, that is if we can find VB, if we can find the potential at VB, then if we multiply it with the Q, then we will get the potential energy of the charge Q at that point. Right? Now, how to find VB? That is the main thing. Now, if you see, the electric field is moving from this side to this side. Right? Now, which side is higher potential, which side is lower potential? So, we know that along the direction of electric field, electric potential decreases. Electric field decreases as well as electric potential decreases in the direction of electric field. So, in the direction of electric field decreases means VA is at higher potential than VB. So, when the charge is moved here, That means the electric field itself is doing the work, and the external work by us is 0 or negative in other sense. So that means that whatever work is done, that is done by the electric field itself. Now how much work is done from moving the charge from A to B? It does not depend on the path, it only depends on the distance. It does not depend on the path, it only depends on the distance that is covered, right? Now how much distance it is covered? It is covered a distance, it is given here x. Okay, so the distance covered here is x. So the work done by the electric field is Ex. So work done by the electric field here is Ex, but since it is done by the electric field, this is negative. Now what is the potential at A? Potential at A is Va. So the potential at B should be this, okay, because it is a conservative field. So whatever potential was here minus the work done, that is the final potential at point B. So the potential energy of the charge at point B is given by Q times Va minus E times X. Now if you see the option, the correct option is option D. Okay. Now a parallel plate capacitor of capacitance C1 with a dielectric slab in between its plates is connected to a battery. It has a potential difference V1 across its plates. Now, when the dielectric slab is removed, keeping the capacitor connected to the battery, the new capacitance and potential difference are C2 and V2 respectively. Now, what we have to find the correct answer. So what the question says, we have a capacitor with a dielectric slab in between. Okay, dielectric slab in between. Initially the capacitance was C1, and after you removed it, now the capacitance is C2. Now which one will be greater? Which one will be greater? We know that capacitor's capacitance without dielectric is less, as when you insert the dielectric, it becomes the times the dielectric constant. So basically from here we can see C1 is obviously greater than C2. This much is clear, right? C1 is greater than C2. Initially it was greater, later on it is lesser, right? Now the battery is still connected. That means what will happen? The battery will always charge the capacitor till the maximum possible voltage. So both cases, so V1 must be equals to V2 and C1 must be greater than C2. So B is correct answer. So you have to use your head, you have to use the logic to answer this kind of questions. A cubical Gaussian surface has a side of length A equals to 10 centimeter. Electric field lines are parallel to the x-axis as shown. The magnitudes of electric fields through the surface ABCD and EFGH are 6 kilonewton per coulomb and 9 kilonewton per coulomb respectively. Then the total charge enclosed by the cube is. So first we have to find, so here it is said that electric field coming through this as 6 kilonewton, okay, per coulomb, and it is exiting with 9 kilonewton per coulomb. So what is the net electric net electric field first we have to find, then we have to find the net electric flux. So what is the net electric field? Net electric field is 9 minus 6 kilonewton per coulomb, right? That is 3 times 10 to the power of 3 Newton per coulomb, right? This is the net electric field. Now what is the flux? Flux is E times area, right? If you have done that EDS integration etc. So E times area. So what is the area? Area of this one surface. What is the area of this surface? Area of this surface is 10 centimeter one side. That means area is 10 times 10, but it is given in centimeter. So it will be 3 times 10 to the power of 3 times area is 10 into 10 to the power of minus 2 whole square, right? A square is the area. Now 10 times 10 to the power minus 2, that means it will become 10 to the power of minus 1, right? So it will become 3 times 10 to the power of minus 10 to the power of 3 10 to the power of 3 times 10 to the power of minus 1 whole square, that is 10 to the power of minus 2. So it will become 30. Okay. Now what we know from Gauss's law, that this flask is only dependent on the charge enclosed by the surface. So what is the charge enclosed by the surface? Charge enclosed by the surface is phi equals to q by epsilon naught, or q equals to phi times epsilon naught. Now what is the value of epsilon naught? Epsilon naught value is given 9 times 10 to the power of minus 12. So what we have to do? We have to use that value. Q equals to phi is 30, epsilon naught is 9 times 10 to the power of minus 12 coulomb. So it will be 32270 times 10 to the power of minus 12 coulomb. Or we can take 1, 2, 3 decimals, 270 into 10 to the power of minus 9 coulomb. Now 10 to the power of minus 9 is what? 10 to the power of minus 9 is, yes, 10 to the power of minus 9 is nano coulomb. Now check the options, which option is correct? So the correct option is this, 10 to the power of 0.27 nano coulomb. Okay. Now why it is positive? Because the net field is outward, that means the charge inside, sitting inside, is actually positive charge. Because if you see, incoming is 6, outgoing is 9. If it was less, suppose incoming is 6, outgoing is 3, then it would have been negative charge. So remember that if the net charge is outflow, that means something is positive inside. If this net is negative, then it is negative. Now 4 bands of color coded resistor of the colors gray, red, gold and gold, the value of the resistance of the resistor. Now this color code of resistor is currently out of syllabus. I will just give you the answer. The answer is this. Okay. If you want a detailed explanation, mention in the comment below. I will explain that, but for most of the students, you should know this is out of syllabus now. A wire of resistance R is connected across a cell of EMF epsilon and internal resistance R. The current through the circuit is I. In time t, the work done by the battery to establish the current is. So what is this? A wire of resistance R is connected across a cell of EMF epsilon naught. Okay. Internal resistance is there. The current through the circuit is I. In time t, the work done by the battery to establish the current. So what is the work done? Work done, I know, I have already told this, is I square RT. Okay. I square RT is the work done. There is one more value I generally use is VIT, vitamin. I always say eat vitamins. So vitamin is another formula, but here V is not given, epsilon is given. Now we know that V is epsilon minus IR. Okay. But nothing, no value is given in terms of this, right? There is no small r given anywhere. So basically they are asking us to find in terms of I. Okay. So I square RT is the only correct answer. Okay. Epsilon will not come in any of the equations because epsilon itself is not the voltage. Voltage is basically epsilon minus IR because there is an internal resistance is present. If there was no internal resistance present, then this could have been also the correct answer. But because of the internal resistance, V is not epsilon, V is less than epsilon, that's why we cannot use it, but we can directly use this formula. There is no issue. Okay. Current is already taken care of. Now, for a given electric current, the drift velocity of a conductor of electrons in a copper wire is Vd and their mobility is mu. when the current is increased, the constant at constant temperature, Vd remains same, mu increases, Vd remains the same, mu decreases, Vd decrease, mu remains the same, Vd increases, mu remains the same. Now you should know that the mobility dependent on the temperature, okay, whereas Vd dependent on the current, that is NEIVED. You have done that expression, right? So basically Vd depends on the current, whereas mobility depends on the temperature. So basically Vd increases and mu remains the same. 10 identical cells, each EMF 2 volt and internal resistance 1 ohm are connected in series with 2 cells wrongly connected. A resistor of 10 ohm is connected to the combination. What is the current through the resistor? So what is the meaning of 10 EMF sources are connected series, but out of that 2 is wrongly connected? What is the meaning of that? So let us explain that. So suppose I have one EMF source like this, another like this, another like this, okay. So these are all connected in series, right? But in between somewhere 2 are wrongly connected. Wrongly connected means their resistance will still be there, but the polarity of the battery will change. That means it will be connected like this. Rest of the batteries are again connected properly. So in between everything is trying to send the current. If you see clearly, every other EMF is trying to send the current in this direction, whereas these two are trying to send the current in this direction. So what is the equivalent EMF? Equivalent EMF will be out of 10, how many are properly connected? 8 are properly connected. So 8 times 2 volts is properly connected, but 2 are wrongly connected. That means they are reverse biased, reverse oriented. Then we can say 2 are in the opposite side. So what is the equivalent EMF? 16 minus 4, that is 12 volts. 12 volt is the total EMF. Now what is the internal resistance of the system? Internal resistance, no matter how the batteries are connected, internal resistance always gets added. So internal resistance, total internal resistance is 1 into 10, that is 10 ohms, right? This is the internal resistance. Internal resistance always gets added, but for potential you have to calculate the orientation as well. Now what is the total resistance after connecting 10 ohm? After connecting 10 ohm, the total resistance is R in plus R, that is 10 plus 10, that is 20 ohm. Okay, this is the total resistance of the circuit. Now what is the current? We know that current is V by R total here. So V is 12, total is 20. This will be 0.6 amps. Okay, so the correct answer is option C. Now this is a very interesting question. This type of question is very common in JEE. This type of question is very common in KCET and also NEET. The equivalent resistance between the points A and B in the following circuit. So here they have given a A and B point, and they have given this combination, and it goes till infinity. Okay, this goes till infinity. So basically they are saying an infinitely long circuit, and they have asked you to find the equivalent resistance. Very difficult. How can you solve this? So what way we can solve it? There is a neat trick for this. So if you cover this part, from here till here, you will see as if this is identical of that. Okay, because this is infinitely long. Okay, it does not matter if you cover this part. If you cover this part, okay, you will see this entire thing is almost exactly same as this, right? Because again there will be another resistance here, and then again it will continue, right? So if you cover this, it does not matter, it looks the same way it was till this point. So we can say if the equivalent resistance of the entire circuit, if the equivalent resistance of the entire circuit say small r, then if you cover this part is also small r, right? If the entire resistance is small r, this looks exactly the same. That means this will also have the same resistance, that is small r. So what we will do, we will do a smart thing. This is a trick, neat trick. You have to be aware of that. So you have to find the point of symmetry when it is symmetrical. So beyond this point, it is again same thing, right? Right? It goes till infinity. So if I cut and open this part, now if I say this part has resistance R, in total resistance, this part will also have resistance R. Now we have cut this part, right? So this R was in parallel here, right? Now what is the total resistance of this circuit? Total resistance of this circuit is also smaller, right? So this one was smaller, I cut a part, that part is also smaller. That is the main thing that you have to understand. If you have any doubt, don't forget to mention that in the comment. This is a very, very important question. Okay, so 2 ohm here, 2 ohm here, 2 ohm here, and this is also equals to small r. Now we have to find the total resistance of this and then equate it to the small r. So what is total? Is first this part is 2 and r is in parallel, then this thing is entirely in series with 2 plus 2. Okay, so what is the combined resistance of these two resistance? 2r divided by 2 plus r, right? R1 R2 divided by R1 plus R2. That is the shortcut way to remember the resistances in parallel. Plus 2 ohm plus 2 ohm. So this is parallel, then this thing is entirely connected in series. This is also equals to R, right? Now let me solve this quickly. So it will be 2r by 2 plus r plus 4 equals to small r, right? 2 plus 2 is 4. Now take this on the other side to 2r plus 2 plus r equals to r minus 4. Now you have to do the cross multiplication. So 2r equals to 2r minus 8 plus r square minus 4r. Okay, so this is the option. Or now what you have to do, you have to take this 2r on the other side. So what it will become r square minus 4r minus 2r minus 6r plus 2r. That means this 2r will cancel. So minus 4r will only be there. Okay, minus 8 equals to 0. Okay, so this is the quadratic equation, but there is no clear root for this equation. Okay, so you have to use Siddharacharya equation to solve this, the quadratic equation rule that you have to apply and solve it. R is equal to minus b. Minus b means here it is minus 4, so minus of minus 4 means 4, plus and minus. Now resistance cannot be negative, so we will ignore this negative sign, we will only use the plus sign here, times b square minus 4ac. b square is 4 square, that is 16, minus 4ac. Now 4, a is 1 and c is minus 8, right? So minus means that minus minus will be plus. AC means 8 times 1 times 4, that is 32, divided by 2a. A is 1. This is the resistance 4 plus, this is 48, right? This is 48. 32 plus 16 is 48. Now 48 is not a square number, then how can we solve it? What is the next nearest number that is the square number? That is 49, right? So we can simply assume this is equals to 49 and we can calculate that. 49 square root is 7 divided by 2, that is 11 by 2, that is nearly equals to 5.5. 5 ohm. Okay, so this is also a shortcut method to calculate the answer. So correct answer is 5.5 ohm. This is very interesting problem. You can remember for 2 ohm value it is 5.5 ohm. You can remember that value for 1 ohm. You can calculate and tell me the answer in the comment below. Okay, now a charged particle is subjected to acceleration in a cyclotron as shown. The charged particle undergoes increase in its speed only between the gap between the d1 and d2, only between the d's. That is the point where it gets accelerated, but unfortunately this is now deleted, so you don't need to put focus on this. Let's move on. The resistance of a carbon resistor is 4.7 kilo ohm plus minus 5%. The color of the third band is color code is also now deleted, but you can answer this 4.7 times 10 to the power 3 kilo ohm. Okay, this part is for tolerance. Tolerance 5% is gold. Okay, but you can calculate this 47 into 10 to the power of 2. Okay, so this is the first color, this is the second color, this is the third color, and they have asked you to find the third color. Third color is 2, that is red. A moving coil galvanometer is converted into an ammeter of range 0 to 5 milliampere. The galvanometer resistance is 90 ohm and the shunt resistance has a value of 10 ohm. There are 50 divisions in the galvanometer turned ammeter on the either sides of the 0. So its current sensitivity is. So the galvanometer used to measure presence of charge. Now you have converted into to measure the voltage. So this is 0, this is 50. So what is the meaning of this? Is also 50. So it measures positive current in this direction, negative current in this direction. So it has a it can measure the direction of current as well. Right. Now what is said is that 0 to 5 milliampere it can measure. So maximum current it can measure is 5 milliampere. Now we have seen the diagram of ammeter, right? This is the ammeter, this is the internal resistance, and this is the shunt resistance. This is the galvanometer. Okay, and this is the shunt resistance. The entire combination works as a ammeter. Okay, this is shunt, this is galvanometer resistance G. Now the current is Ig, and this current is Is, and the total current is I. Now this current 5 milliampere is I. Okay, I is 5 milliampere, maximum current it can measure, right? So I is 5 milliampere. You have to find Ig. What is the value of Ig? Now if you remember, Ig is given by Ig through galvanometer, then this resistance divided by these two resistances G plus S times the current that is entering I. Okay, this is the formula. There is a derivation. Now derivation is no longer part of your syllabus, but this formula is still there. So you have to use this to find the Ig. So what is the value of the S? The shunt resistance has a value of 10 ohm. So shunt resistance 10 ohm, G is 90 and S is 10, right? So it will be 10 divided by 100 times 5 milliampere. So what is Ig? So if you find Ig will be 5 divided by 10, that is 0.5 milliampere. This is the current that is being allowed through the galvanometer. Now this much current, when this current is flowing, what is the deflection of the galvanometer? The galvanometer shows 50 division deflection, right? So deflection is 50 division for 0.5 milliampere current. So how much deflection it will show for each of that division, that is called the sensitivity. So sensitivity can be measured as sensitivity, I am using a different type of S, is equals to sensitivity is maximum division divided by the maximum allowed current. Now this is milliampere. Okay, so it is 50 divided by 0.5 times 10 to the power of minus 3. Now this is division per ampere. So the unit is division per ampere, not ampere per division. Okay. So now calculate this value. What will be the value? So 0.5, 50 divided by 0.5 is 100. Okay. 50 divided by 0.5, 1 point will go up, that will become 500 divided by 5, that means 100. Now this 10 to the power of minus 3 will go up and it will become 10 to the power plus 3 division per ampere. Okay. So if you combine this, this will become 1 times 10 to the power of 5 division per ampere. Okay. The correct answer is this. Okay. If you have any doubt regarding this, you can mention that in the comment below. This is also a very good problem. A positively charged particle of mass m is passed through a velocity selector. It moves horizontally rightward without deviation along the line y is equal to 2 mv by qb with a speed v. The electric field is vertically downward and the magnetic field is into the plane of the paper. Now the electric field is switched off at t equals to 0. The angular momentum of the charged particle about the origin after time t equals to pi m by qb is. So when there is a what should I say? When there is a charged particle moving in a magnetic field, then it will start moving in a circular path because they are perpendicular to each other, right? Now here at the beginning, before t is equal to 0, before time t is equal to 0, electric field and magnetic field both are active, and at that time this charge was moving freely without deviating. That means it was being selected. So when it is selected, we know that Q into E, Lorentz force, both components are equal. QE is equal to BV, QBV. Okay, BVQ. I am just writing for simplification. So QQ cancels. So E by B becomes the velocity V. Okay, so this is the expression for E by V, B. Now, what is the angular momentum? Angular momentum is vectorially, it is R cross MB, right? Now we are not using vector notation, so we can simply use this thing, and they are, since they are in the perpendicular direction, we can simply use RMV. Now what is the value of R? So R value you can calculate using the term that is circular motion, so it will move in a circle. So circle means there will be a centripetal force. Centripetal force means mv square by r is equal to QBV. Now electric field is removed, so you can find the value of R from this expression. R will be mv by QB, right? You have done that. This is magnetic field due to a moving charge, right? Now put the value of R here, mv divided by QB. Now mv, this is also mv, right? This is also mv, right? So what we can write? We can write angular momentum L equals to m square by QB times V square. Now what is V square? V we just calculated. V is E by B, right? So we have to substitute that value, then we will get m square E square divided by Q B cube. Now if you see, none of the option has given this answer, so we can simply say this is a wrong answer. Nothing, no correct answer is given in this question. So this is a bonus question. Question number 20. Curie's temperature of cobalt and iron are 1400 Kelvin and 1000 Kelvin respectively. At T is equal to 1600 Kelvin, the ratio of magnetic susceptibility of cobalt to that of iron is. Now this is a deleted syllabus, deleted portion question. It is deleted, and the correct answer is, in this case, is A. I am not going to solve it. The torque acting on a magnetic dipole placed in an uniform magnetic field is 0 when the angle between the dipole axis and the magnetic field is. So the torque acting between magnetic dipole placed in uniform magnetic field is 0. That means they are either parallel or they are anti-parallel, because torque means is a cross product, right? Cross product means they will either be parallel or they will be anti-parallel. That means the angle is either 0 or 180, and 180 option is not given. So only correct option is 0. Horizontal component of Earth's magnetic field at a place is 3 times 10 to the power minus 5 Tesla. The angle of dip at that place is 45 degree. The resultant magnetic field at that place. So I am just solving it. This is also deleted part, but in JE it is there, so I am going to solve it. So this is the angle of dip, that is given 45 degrees. This is a horizontal component, BH. This is equals to B. If this is the magnetic field, B, this is B cos theta. Okay, so B will be BH by cos theta. Okay, now BH is given 3 times 10 to the power of minus 5, and cos theta is cos 45, that is 1 by root 2. So it will become 3 root 2 times 10 to the power of minus 5. So the correct answer is this. Okay. A proton and an alpha particle moving with the same velocity enter an uniform magnetic field with their velocities perpendicular to the magnetic field. The ratio of radii of their circular path. So how can we calculate the radius of the circular path? I just explained. mv square by r equals to qbv. Okay, so one of the v's will cancel and r will become mv by qb. Okay, so there is one trend in KCET. If one question comes from one formula, there are multiple chances of getting same similar question having multiple same formula. Okay, it has been repeated in 24 as well, and we are seeing the same trend in 23 as well. In 23 there are multiple questions based on different pairs. Okay, there are 2 questions from same formula. It happens multiple times. Okay, so here r is mv by qb. Now for a single proton, there is only one proton is there, so the mass of proton is there. Okay, and v is same for both cases, and charge is only 1 plus e, right? 1 plus e into b. Okay, 1 plus e. Now what is in case of helium? What is the situation? For helium, how many protons are there? 2, right? How many neutrons are there? 2. Neutrons and protons are almost same in mass, right? So we can write here 4 mp. Okay, so 2 neutron, 2 protons, 4 total, 4 nucleons, and they have almost same mass, so we can write 4 mp. V is same, and 2 protons, that means double charge means plus 2 EB. Okay, that is 2 mp V by EB. Okay, so this will cancel, we will get this. Now what is this? This is the protons radius, right? Now what is the question? Which is to what? The ratio of radii of their circular path. That means first one, which one is first? First one is proton, second one is alpha. Okay, this is very important. Even if you have solved the problem correctly, if you have not read the question properly, even after solving you might answer it incorrect, because they have given 1:2 as well as 2:1. You have to be correct and be careful which one is correct, because you have understood that this is either 1:2 or 2:1. Now which one it will be? So proton is to helium. So proton is to helium means 1 by 2 is equals to proton by helium. So proton is to helium is 1:2. So 1:2 is the correct answer. So don't be in a hurry that okay 2 times we got, that means 2:1. Okay, that is the basic mistakes students are making these days. So if you are solving the question properly, just take one more second, read the question once more and make sure that you are answering the question properly. A metallic rod of length 1 meter held along the east-west direction is allowed to fall down freely given the horizontal component of Earth's magnetic field is BH 3 into 10 to the power minus 5 volt. The EMF induced in the rod at an instant t equals to 2 seconds after it is released. Now, even though the horizontal component of Earth's magnetic field is deleted, this question is still relevant. They can ask the same question by saying there is a uniform magnetic field say in the horizontal direction, and if you have dropped a metallic rod in that magnetic field, what will be the induced EMF? Same question, similar question may come in your KCET exam. Instead of horizontal component, they will mention horizontal magnetic field. So this concept is important. Even though the magnetic field, Earth's magnetic field is deleted, the question can be reframed such a way it can cater to your syllabus, present syllabus as well. So let us see how we can solve this problem. So the length of the rod is L. Okay, the horizontal magnetic field, I am not saying horizontal magnetic component of Earth's magnetic field. The horizontal magnetic field is given as 3 times 10 to the power of minus 5. I think the unit is wrong. Okay, unit is not volt, it will be Tesla. We know that when the rod is falling, it is covering some area. Okay, it is covering some area. Right now, we know that the magnetic flask is basically B times this area. Right, B times this area. Now, what is the area? Suppose after some time it moved the distance, say y, because it is y direction. I am saying suppose it moved the direction y. Okay, and this is length L. Okay, this is length L, means this will be B times L times y. Right, B times L times y. Now, what is the rate of change of magnetic flux? That is important. That is the induced EMF. Induced EMF is rate of change of magnetic flux. Now, B is constant. It is constant throughout, right? L is constant. L is not changing. The length of the rod is not changing. So, only thing that is changing is y. So, it will be dy by dt. Now, what is dy by dt? It is falling. That means that is the speed of the rod at that instant. So, BH L into V or BVL. This is a formula. You should remember. If you already know that formula, you can directly use it. I have just, for the sake of explanation, I have solved this. Right. This is the this is the magnitude of the EMF, because EMF is negative of that, but we can safely take the magnitude of that for finding the EMF. Now, so EMF is basically BVL. B is given, V is not given. What is V? This is falling under the action of gravity. That means, what is the acceleration? Acceleration is G. We know that V equals to U plus AT, in this case GT, right? U is 0, G is 10, and time is after 2 seconds. So, V is 20 meter per second. Right, now put the values here, take everything in SI unit. 3 times 10 to the power of minus 5, V is 20, L is given 1 meter. L is given 1 meter. So, it will be 6 times 10 to the power of minus 4 volts. Okay. A square loop of side 2 centimeter enters a magnetic field with a constant speed of 2 centimeter per second as shown. The front edge enters the field at t equals to 0. So, it is moving In the magnetic field is to inside the paper, because cross represents inside the paper and dot represents outside the paper. So this is into the paper, this is out of the paper. Remember these two symbols, okay? So this side is entering the magnetic field at time t equals to 0 second. Which of the following graph correctly depicts the induced EMF in the loop? Take clockwise direction positive. Very, very important thing. Now if you see all the graphs, in all the graphs the maximum value of induced EMF is given same. You can calculate, but the values are already given, so basically they are not asking you to calculate this value. If these values were different, then you would have needed using the same formula BVL and calculate the induced EMF value. But they have given all 4 cases, they have given the same value. That means they are not asking you to find the maximum induced EMF. What they are asking you to, which pattern it will be. Now in each cases you see between these 2 points, there is no EMF. So EMF is 0. Between all these cases EMF is 0. So between all these 2 points the EMF is 0, right? So this is also they have not asked you to. So what is happening, let us understand. When this loop is entering this magnetic field, the current is increasing. Current is increasing, then when it is exiting the field, again current is increasing. In between these 2 points the current is there is no change in magnetic field, that means there is no current in when this loop is completely inside the magnetic field. Now if the current is increasing in the positive direction or in the negative direction, for that we have to use this take clockwise direction as positive. So that is the only hint given. This is the main thing. The entire question is dependent on this thing. So basically this is not correct. It is increasing means it is not constant. So square wave means this is constant, right? Or rectangular wave, this is a rectangular wave. Rectangular wave means it is constant. It is not constant. It is either increasing or maybe it is decreasing based on the direction that we consider positive. Okay. So either A or C is correct. These 2 options are incorrect. Okay, these 2 options are incorrect. Why these 2 options are incorrect? Because here it is flat. For induced EMF, this will never be flat. It will always be a time varying thing. Now, when the loop is entering, the magnetic field is increasing, right? Magnetic field is increasing. Now, magnetic field is into the paper. So what will happen? This loop will try to induce a current in such a way, this opposes the increase that is inside the paper. So inside the paper was this, so it will try to induce a current which is in this direction, that is opposite direction. We know that whatever direction of the magnetic field, current, the thumb represents the magnetic field, right? So this loop will try to oppose the inside magnetic field by having a current of itself in this direction. He is the rebel. Okay, he is the rebel in the family, like you. Right, like you don't want whatever your parents say. So basically this is the magnetic field, that is the parent. So when they are entering, they try to rebel and they say we will do opposite exactly what we are being told to. So they are doing in this direction, right? So this is, what is this direction is? This direction is anti-clockwise. So anti-clockwise direction means it is negative, because clockwise direction is positive. That means it will actually increase in the negative direction. It is increasing in the negative direction, then again it is coming to 0, then slowly after some time when it is exiting the magnetic field, it will increase in the positive direction. Okay, then slowly again it will become 0, right? So now the correct answer will be option C. Now, in series LCR circuit at resonance, the phase difference between voltage and current is. Very interesting, simple question. At phase difference, we know that circuit is neither capacitive nor inductive. It is fully resistive. Okay, in a fully resistive, because XC equals to XL, and we know that Z equals to square root of R square plus XL minus XC whole square. So basically at resonance this component becomes 0 and the impedance becomes fully resistive. So the circuit is fully resistive. In fully resistive circuit the phase difference is obviously 0, right? Ohm's law. I and V are directly related. There is no phase difference between them. So phase difference is 0 at resonance. An ideal transformer has a turn ratio 10 when the primary is connected to a 220 volt 50 hertz AC source. The power output is. Now this is a full question. This is a way that you should be distracted to answer this question. You should know that in ideal transformer power is always same. Power is corresponds to energy, and energy can neither be created nor be destroyed. In non-ideal transformer some energy may be converted into heat, some energy may be converted into other forms of energy, but in ideal transformer, that is, there is no loss of energy, the power transfer should be, power output should be as equal to the power input. So equal to the power input. So power output should be always equal to power input in case of ideal transformer. Now question number 28. The current in a coil changes from 2 ampere to 5 ampere in 0.3 seconds. The magnitude of EMF induced in the coil is 1.0 volt. The value of the self inductance. Now we know that the induced current is given by, magnitude of induced current is given by magnitude of induced EMF. Magnitude of induced EMF is given by L di by dt, right? So this is self inductance, EMF is 1 volt. Okay, this is the self inductance we are trying to find out. What is di? It is changing from 5 to 3 in time 0.3, right? Sorry, one more mistake I made. It is 5 minus 2. 5 minus 2. So L is 0.3 divided by 3, that is 0.1. Okay, so L is 0.1. Now there is no option given in 0.1, right? So what we have to do? This is in Henry. This is in Henry, right? So what we have to do? We have to convert it into millihenry. That is 100 millihenry. So 100 millihenry means this is the correct option. So sometimes even after solving the question, you have to check, since everything you have used SI, so this will be in units of Henry. Then you have to check and you have to adjust the unit. Now ratio of the magnitudes of electric field to the magnetic field of an electromagnetic wave is of the order of, so ratio of electric field to that of magnetic field in free space is nothing but speed of light, that is 3 times 10 to the power of 8 meter per second, right? So what is the correct answer? Correct answer is this. So ratio of electric field by magnetic field is C. Then from there we can see. Now in the future maybe they will ask what is the ratio of magnetic field by electric field. Then it will be 10 to the power minus 8, but it will be second per meter. So be careful about that. Last question of today, this is easy question. For a point object, which of the following always produces virtual image in air? Very important, very conceptual question. Now plano convex lens means one side is plane, another side is convex. It may produce virtual image in certain cases, but in some cases it will also produce a real image, right? Because it has a part geometry of convex lens. Biconvex lens, we know biconvex lens mostly produce real images, except few cases where it is less than focal length, then it produces virtual length. So in some cases it produces real image, not always. So remember, it should be always. Convex mirror always produces virtual image. Convex mirror, there is no single case where convex mirror produces a real image. Okay. Concave mirror produce virtual image as well as real image based on the distance. So the correct option is option C. It always produces the virtual image. So far, if you have liked our videos, don't forget to subscribe to our channel. We'll bring part 2 of 2023 question paper very soon. So thank you for watching this video, and I'll be back soon.